All right, we are solving linear equations, and what we want to do is get this variable all by itself on one side of the equal sign. How we will do it is we will get do the order of operations backwards. So isn't this the term with the variable in it? Is there anything being added or subtracted to that term right now? This plus 3. We need to get rid of this plus 3. How will we get rid of the plus 3? And it's up to you now. This is not Algebra 1. We do not need baby steps. You do not need to be this person of minus 3 and do this. If you need to do that, do it. But I feel at our level, we can just subtract 3, and wouldn't the 5x come down? The equal sign will also come down. And what is 23 minus 3? It is 20. Like I said, if you need to show the baby steps, you show those baby steps. But your job as this year goes on is to make those go away because they take too much time to write all that stuff down. Now, is x all by itself? No. There's a 5 with it, but is it a plus 5, times 5, minus 5, or divided by 5? What's going on there? Times 5. How do you get rid of times 5? Divide both sides by 5. And you do not need to do this. You do not need to be no. You can if you want to, but don't we just need to divide both sides by 5? So you'd have a 5 there. 5 divided by 5 is 1, and the x is still there. And what's 25 divided by 5? Thank you, my bad. What's 20 divided by 5? 4. And that's our final answer, correct? We will circle it. And now we will take, well, the next one here. We got a for a variable. Let's get a all by itself. We'll get rid of this minus 14 first. So how do we get rid of the minus 14? And we'll do that to both sides. 4 plus 14 is 18 equals 3a. Cool. It's all right. We work in numerical order. I don't like to go down. I like to go over. And then get a all by itself by doing what? Divide by 3. What's 18 divided by 3? And we will do a lot of non-calculator tests and quizzes in here. Things like, I know we're knocking the cobwebs off because it's the first day back from summer vacation and all that stuff, but by a couple of weeks from now, you should be expected to know your basic addition, subtraction, multiplication, like 18 divided by 3, etc. Cool? Number 3, first move is to do what? Subtract 5 from both sides. So we'll have a 2y come down, equal sign comes down, and 19 minus 5 is 14. I would like you to notice how nice and neat my work is. See how all my equal signs are lined up. It's not all over the place. Nice and neat. What you see up here is what I expect to be written on your homework and homework quizzes. And then final move here is to divide both sides by 2. So y will equal 7. And we circle them for our final answer. Cool? Why don't you and your pal sitting next to you do number 4 for me. So please pause the video and get that done. Cool? So when we subtracted 6 from both sides, we got a negative 35. Then our final move is to divide by 5. And help me out, c is negative 7. On number 5 right here. We got a little bit of optical illusion. What's our first move again? Subtract 8. So what comes down when we subtract 8? There's a negative in front of there, right? It's not 5w, it's minus 5w. So what you see comes down, and then if this helps, do it. But I want to show you something here. We don't do things half-assed. Oh no, he cussed, right? We don't do things that way. Here's what I mean by half bad worded right quick. Is if you're going to subtract 8 right here, you have to do it to both sides, right? You can't just put a minus 8 here and not do it here. If you're going to show baby steps, you do it the right way. You do it to both sides. If you're not going to show baby steps, then you don't do it. But we don't do half baby steps. We don't say, I need some help here. And that takes a little while for kids who had a not-so-hot algebra teacher to get used to. But these have the same sign, so we'll add them together. What's 37 plus 8? 43, and then we attach the common sign. 45, my bad. Sorry. First day, man. Negative 45. Then let's divide both sides by negative 5. And, oh, man, what's negative divided by negative again? Positive. So positive what? 9. You and pal, get number 6 done. Please pause the video. Get that done. So we should have got b equals negative 6. On the next one, fractions. There's no such things in fractions in my world. This symbol right here is really a division sign right here. It's a division sign. And we were pretty comfortable right here. Wasn't this a variable times a number right here? Just a variable times a number? Well, here, it's a variable divided by a number. Very easy to deal with. But would you agree that this is the term with the variable in it? Is there anything being added or subtracted to that guy right now? This minus 8. Our first move is to get rid of that minus 8. How do you get rid of a minus 8? You add 8 to both sides, and n over 3 comes down, and we will add 8 to both sides. What's negative 2 plus 8? It's 6, and the equal sign's still there. Cool with that. First move. Next move is to get n all by itself. There's a divide by 3 hanging out with it. How do you get rid of divide by 3? You multiply both sides by 3. So this means the n would come down, and what's 6 times 3? 18. You just undo the operation. Right? You're doing the order of operations backwards. Just going to undo it. So let's try number 8. Sure, it's a cool little fraction. Is there anything being added or subtracted to the term with the variable in it first? This plus 5. So let's get minus 5 from both sides. And x over 4 comes down. And that'll equal 1 minus 5, which is negative 4. Right? And now to get x all by itself, we've got to get rid of that divide by 4 by doing a little bit of multiply by 4. And what would we get over here? Negative 16. Very nice, very nice, very nice. 9's got a little bit of trick involved with it, though. Are we okay with the one so far? First move, number 9, is to do what? Add 4 to both sides. Right? You don't always subtract stuff over. You do the opposite of this. This is a minus 4, so we add 4. But negative h over 3 comes down, and 13 plus 4 is 17. So far, so good. Now, this negative symbol kind of messes with people's heads, especially when it's especially when it is right in front of the fraction bar. It's only in one of those places. It's either in the numerator or in the denominator. It is not in both places. So I prefer to think of the negative in the denominator. Isn't there a divide by negative 3 hanging out with h right there? How can I get rid of a divide by negative 3? Multiply by negative 3. So h will come down, and then I'll have a negative answer for sure. And like I said, if you need to punch that in, you punch that in. But you can think of it as this. Do you know what 3 times this guy is? This number right here is 10, right? Because it's the 10 plus the 7. What's 3 times 10? 30. What's 3 times 7? 21. So you're adding 30 and 21 together, which is how much? 51. And it came out negative because it was a negative 3 times 17. Nice and neat. Why don't we try the next one? So please pause the video and get the next one done. Very nice. Cool with that? Why don't we get the next 2 done here? Next 2. Get them both done. So pause the video and get those bad boys done. People. So we should have got these, as you can see. Now on the next ones, we got variables on both sides. So our rule is we try to get all the stuff with the variable, with the x's on one side and all the constants on the other side. Constants are the stuff without the variable in them. So it doesn't matter which way you move, and it doesn't matter what you do first. I'm a fan of always trying to get the variables to one side first, moving the variable stuff. And couldn't we subtract this 7x over here? Or we could add 3x over there. What do you want to deal with? A negative number or a positive number? So what do you say we add 3x to both sides first? So this minus 4 will still be there. Equals comes down. And 7x plus 3x is 10x minus 6. Don't try to do too many steps at once. We're still not the strongest math students. It's no offense to you, but the more steps you try to do at one time, the more mistakes you'll make. Just move the x's over first. Cool? Now what's our next move? Add 6 to both sides. So that would be negative 4 plus 6 is 2, and that would equal 10x. Cool? Now it's time to slow down, because the brain fart answer would be x equals 5. And this one ain't going to turn out to be x equals 5, because what do we have to do to solve for x? Divide by 10. And this really turns out to be x equals 2 divided by 10. Are you with me on that? 2 divided by 10. Now that is the right answer, but it's not the right answer, if you know what I mean. Because what do you know about 2/10? It can be simplified because both of those are even. Doesn't 2 go into each one of them? So you can just leave that if you want to and then bring it down one step further and say x really equals how much? 1/5. Now what if you gave me an answer of x equals 0.2? That tells me you punched it in your calculator. Which, like I said, there's nothing wrong with punching stuff in your calculator, but I've always said this: algebra problems should give me no decimals, unless there were decimals involved with it in the first place. This had no decimals to start with, so I shouldn't get any decimals for an answer. I'll give me a fraction. Now, story problems is a whole different deal. Like, there's a nice little story involved. It's a real-life situation. Maybe we'll have decimals. But this is not a story. This is just a straight-up algebra problem. You will not give me a decimal. Cool? Next guy. First move. What do you want to do? Let's move the k's to the same side. Which one do you want to move? Subtract this k over here. Right? You got to realize that is 1k right there. The number in front of the k is a 1. The coefficient of k is 1. So you got 4k minus 1k, which is really 3k, and the plus 8 was over there still also, and then the minus 10 comes down. Yeah? Nice. Next move. Subtract 8. So you got 3k coming down. You got a negative 10, take away 8. Is it negative 2? Is it 2? Is it negative 18? Or is it positive 18? Negative 18. You're going to lose 10 things and lose 8 more, so you got negative 18 right here. Just takes a little bit of, oh yeah, we all make mistakes. Don't be ashamed of making mistakes. Just a baby thing. And then finally divide by 3, and we got what? Negative 6. Very nice. Next one. Please pause the video and get that done. And hopefully, on number 15, we got a equals 2. Are we all right with that? Next ones. Oh my, oh my, oh my. Not only do we have variables on both sides, we got fractions all over the place, correct? There's many ways to go about these problems. You could just kind of do it the same way we were doing. You could do it another way. So I feel my job is to show you the easiest possible way to get this done. Depends on, first of all, your denominators of these fractions. Isn't this one got a 3 for a denominator, and this one got a 2 for a denominator, correct? If we wanted to just subtract them over, do you remember what you need to have to add or subtract fractions? Common denominator. These do not have a common denominator, so it's not going to be an easy task to add or subtract them, correct? So I say, let's get rid of these fractions completely possible. If we can just get rid of these fractions, we will do that. So I want to look at these two denominators right here and realize what's called the least common multiple between those. If I wrote a list of multiples of 2, are you all cool with this? 2, 4, 6, 8, 10. These are multiples of 2. And if I wrote a multiples of 3, 3, 6, 9, 12, 15, those are multiples of 3, right? What is the smallest number you see in both lists? That is what's called the least common multiple in this. 12 is also a common multiple if I were to continue that list out further, but it's not the smallest one. 6 is the smallest multiple in both lists. So if we do one of these, let's throw this whole mamma jamma in parentheses and take every term times 6, those fractions will go away. Now it's been a while. I want to refresh your memory on what terms are. Terms are separated by addition signs, subtraction signs, and equal signs. I'll say that again. Terms are separated by addition signs, subtraction signs, and equal signs. So you see, here's a term, here's a term, here's a term, and there's a term. There are 4 terms inside of that set of parentheses that we put. So let's do a little bit of distributive property right here. And people are like, whoa, 6 times 2/3, how do you punch that in? Well, you can do that mentally because isn't this a common multiple of it? Ask yourself this. How many times does 3 go into 6? Right? This is a divide by 3, so you're seeing how many times it goes into. How many times does 3 go into 6? Twice. Take that result times your numerator. 2 times 2 is, so that's really 4, and the n comes down. I'm going to explain that again. I said I took this denominator of 3. It goes into 6 twice, the number 2. I will take that times the numerator and get a 4 out of that. Cool? Now don't forget you got to take 6 times 8 right here. And what's 6 times 8? It's been a while. I understand. It's 48. 6 times 8. I understand. We got to refresh our memory. Cool? Now this one should be no big thing, taking 6 times 1/2, but it's the same process. How many times does 2 go into 6? 3 times, take it times your numerator, and what do you still get? And would you all agree that half of 6 is 3? All right, so you have 3n plus how much? And the big oopsie is we forget to take that 6 times that whole number there still. You know, you still got to take 6 times 2. Cool? Now solve this equation for n. Much, much easier. So we cleared the fractions on that bad boy. We cleared the fractions. Now we can solve this muy buenoer. Very gooder? Yes. So I'll subtract 3n. N plus 48 equals 12. And then subtract 48. Like I said, it's okay to punch stuff in. If you were not having a calculator, make sure you get one now that you saw what I recommend to buy. Hopefully you bring a calculator. We're okay with n being negative 36. We down with the pound? Next guy. Could we clear the fractions? You bet we could. There would not be a problem trying to clear the fractions. Would I clear the fractions? No, I would not. Look at all the denominators involved. Tell me about them denominators. They're the same. So I can add and subtract those fractions really easy because they all have the common denominator already. How about we try this move? Can we get rid of this minus 3/5 y? How do you get rid of a minus 3/5 y? Add 3/5 y. So here's what I'm trying to do. I'll do a little bit of side work. I'm trying to take 2/5 plus 3/5. My bad. 2/5 plus 3/5. Correct? Denominator. Should it stay 5 or should it become a 10? Stays 5. Add your numerators together. 2 plus 3 is? So that really is 5/5. Can that simplify? To the number 1. So you have 2/5 y plus 3/5 y is 1y. Correct? Boom. Very easy. Could you clear the fractions? You bet. But since they had common denominator, we didn't need to, and everything else is still there. Rock on. The minus 8's still there. The 9's there. And now we just got to get y all by itself. So it's all about if you had common denominator or not. So y equals 17. Yeah? Why don't you try the next one for yourself? Please pause the video and get that done. If we add 4r to both sides, right? What's a negative 4r plus 4r? It's 0 r's, right? And we don't just say 0 r's, they cancel each other out, right? So you're left with this, 5 equals 5. The variables disappeared, meaning one solution. See, we got a solution on our previous problem. We got y equals 17. No more variables. There's either going to be two situations. We will either have no solutions to this at all, meaning you can put any number you want in and nothing will work, or there will be infinite solutions to this. And you all know what infinite means. What does infinite mean? Like as many as you want, forever and ever and ever, right? So to answer the question is you got to look and do a little yes or no statement. Does 5 equal 5? Yes or no? Yes. That means that there are infinite solutions to this. Infinite. The word infinite is spelled with all I's, except for the last letter is an E. Infinite, with an E at the end, solutions. What if it wouldn't have been 5 equals 5? What if it had been like 5 equals 7? Do a yes or no problem on that. Does 5 equal 7? No. So how many solutions would there be then? No solutions. If you say no to the yes or no question, there are no solutions. If you say yes to it, there are infinite solutions. If there's still a variable left, there's one solution. Sometimes there's more than one if it's a quadratic, but this is linear. We're okay with that. So just realize freaky things happen. Don't let it bother you. One solution, no solutions, or infinite solutions. Next, backside. Who remembers the generic formula without looking on your cheat sheet for slope-intercept form? Y equals what? Mx plus b. Very nice. X and y are just plain old variables, like your x-axis and your y-axis, all that cool stuff. Which one of these is the slope, m or b? M is the slope. Slope is rise over run kind of thing, right? And b is the y-intercept. So, hey, very easy. You need two things to write the equation of a line. You need the slope and you need a y-intercept. Do we have them both on number 19? So let's write that in slope-intercept form. It'll start with y equals. Slope comes first, so that's 2/3. There's got to be an x next to it. And Please try to make it not look like it's in the denominator. Like, don't put the x right there. You see how that looks like that x is in the denominator? Put it off to the side a little bit, you know, kind of in the middle. And then, whoa, the y-intercept, it's not like they just say the y-intercept is like 4 or something. It says it's at this ordered pair, 0, 5. Like, this is the x value, this is the y value, because this is the place on the graph, the ordered pair, of where the line crossed the y-axis. So the y-intercept, notice the x value. Tell me about the x value of the y-intercept. It is always how much? 0. You need this number right here. That's your b value, 5. And it's a positive 5, so you put plus 5. Sound cool with all that? Now let's graph it. Start where? Where do we start when we graph a line? Well, not necessarily at 5. At the y-intercept, correct? On which axis? The y-axis. That's why it's called the y-intercept. So we put a nice, neat dot right there. I'd like you to watch me graph just so you do it the same way, because everybody graphs a little bit different. So start at your y-intercept, put a nice, neat ordered pair. Cool? And then I want 4 points on our graph, if possible. Sometimes you cannot. So the slope is rise over run or run over rise. And you always want it to be a fraction. Don't ever put any decimal there for a slope, like 0.5. No, 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 no. 1/2, right? You need a fraction. So you can rise and run. So from this point, we want to rise how much? So 1, 2, and then run 3. And how come I went up instead of down? Because rising could either be up or down. Positive 2, right? So rise 2, and then which way should I run? To the right or to the left? 1, 2, 3, because it was also positive. Then put a point right there. Cool? So get that done. Then go from this point and do the same thing. I want 4 of them. So rise 2 and run 3. And put another point. So far, so good. And if I go from this one and rise 2 and run 3, I can't get it done. Don't imagine. Don't imagine it's like 1, and then it's probably like right here. Don't imagine I can't go up 2 anymore. But where could I have went instead of up 2 and to the right 3? Down 2 and to the... Because tell me about negative over a negative. What kind of number is that really? It's still a positive. So down 2 and to the left 3, right? And those should all line up because it's linear. Then you take your straight edge, which is your geometer in this case, and you connect the dots. Watch this, though. You connect them and make your line go through the grid. Do you see how this thing is further than the grid? Don't, like, just quit it. Don't put a line like right here and say, there's my line, and put it at, no, no, no. I don't want that green one. I want that red one, because it goes on forever and ever and ever. And how do you really know it goes on forever and ever and ever? What does every line have on it? Arrows. Put just some arrows on there. That's quick refresher. I hope that rang a bell for you on slope-intercept form. Now we can rock and roll through these. Next one, do they give me a slope or do they give me a y-intercept? So let's write the equation in slope-intercept form. Let's get that done. So y equals what? Negative 7/3 x. And the x gets forgotten a lot. You know, it's like, oops, I forgot to put the x. Just be careful, take your time. Now let's graph it. Starting where? Oh, are you kidding me? Start at 1, and then go down 7. How come down 7? And then which way 3? To the right 3. And then I can't go down 7 again. So instead of going down 7, I could go up 7 from my original green point here, 1, 2, 3, 4, 5, 6, 7, and then to the left 3, right? And then take your straight edge and connect the dots. Cool? Why don't we go ahead and get the next one done? So please pause the video and get that done. Here we go. So on our next one, first move, we got to get y all by itself on one side of the equal sign, so we'll add 2x to both sides. So 5y will equal, now what order should I put these in? Should I put 15 plus 2x, or should I put 2x plus 15? So we're trying to put it in slope-intercept form, so you want the stuff with the x to come first, right? Now what's our next move? Divide all terms by 5. How many terms are there in this puppy? 3 different terms, so this will turn out to be a y. 2 divided by 5, should I put 0.4x? What should I put? 2/5 x, and then 15 divided by 5 is positive 3. So we'll graph that puppy. We'll start at 3 on the y-axis, and then rise 2, because it's positive, and run 5. And we'll do it again. And I like to have 4 points, so I want to go down 2 and to the left 5 on the other one. Sometimes you can't get 4 points on the graph, depending on what your slope is. But if you can get 4 points, please fit 4 points on there, and then connect with the straight edge through the grid. Let's go for the next one. We want to graph it. We want it in slope-intercept form first. First move, what do we want to do? Got to watch the order, right? It's not always this guy's got to move. What's our first move? Subtract this 8x over. So watch this. What do you think about that bad boy? Is that good or is that not quite good enough? I subtracted 8x. Didn't this go over there and I put that right there? Oh, see that minus sign right there? Doesn't that need to come down with it? Watch that optical illusion. It's not a 2y. It's a minus 2y. Cool? And that happens to the best of us. We make that little brain fart right there. And now we finally will get rid of that times 2 by dividing everything by a negative 2. And negative divided by negative is positive. And this 10 divided by negative 2, isn't that a minus 5 right there? All right? I don't want to go too fast. We okay? And then down here at negative 5 on the y-axis, that's my y-intercept. My slope's 4, so that means I'll rise 4. 1, 2, 3, 4. Then should I just put a dot there? I got to run. Well, how much am I supposed to run? 1. Because this is really a fraction. It's 4 over 1. Right? So it's rise 4, run 1, rise 4, run 1. Cool. Then connect the dots with the straight edge. Excelente. 2 more. Get them both done. Work together, etc. So why don't you pause the video, get those puppies done. So here's number 23 to check yourself. And then you can move right on over to number 24. There's our last one right there. Tell me what you know about slope if this is a positive number. If the slope is a positive number, isn't 1/4 a positive number? Tell me about that line. Which way is it going as you look from left to right, up or down? Isn't that going up from left to right? And negative slope goes down from left to right. Cool. So that's it, baby. That's just a nice, quick algebra review.